right, we're in our brand new unit, Unit 8. There's our unit guide, and here we go. Today's date is Tuesday, February 2nd, 2-2, oh nice, 21. Our objective today, Teflon.
Use both positive and negative differentials to equate and to answer questions about rate.
Yeah, we pronounce it differential. I know it has IAL, which kind of sounds weird, but you just say differential as if there's no I. All right, so rate equations or differential equations. They just talk about rates. So let's talk about some three basic things about them. Let's see, size, 16 font. I'll type these so they look really nice for the notes. First, they measure how fast something is changing. So type that verbatim. They measure how fast something is changing. Because it is literally an equation just talking about its rate. So it's an equation that maybe is talking about a velocity. Velocity is a rate. They always have the same type of units. So units are always some unit. So I'll say like a box here. Let's do box. It's some unit. I'll say unit per time. Like people per hour, millimeters per day, something like that. And lastly, as I kind of talked about number one, it's basically velocity. It's the same as velocity. Which, if you want to dig a little bit deeper into that, what is velocity? It's how fast position is changing. So the easiest way to think about differential equations, it's someone already took the first derivative for you and they gave it to you. We're looking at first derivatives today. All right. Fiona, can you read example 1 for us, please?
A cylindrical can is used to measure rainfall and storm drain. The can is initially empty and rain enters the can during a 60-day period. The height of water in the can is known by the function S, where S of t is measured in millimeters. The rate at which the height of water is rising in the can is given by S prime of t equals 2 sine of 0.02t.
There it is. Okay. Well, I'm going to draw a picture because I just feel like it always makes me understand what's going on in the problem. So I have this cylindrical can, and it is important. It does give us a start amount, and that in our last unit that was really important because we were always trying to find end position, and end position was start plus change is equal to end. So our start in this case is 0. So if we ignored it, we would have still gotten the question correct. But initially empty, I'm going to go ahead and write start above that. Our start is 0. We don't have any rain in the can. And eventually, over time, we're going to have this filled with water. So there's my very amazing drawing of water in a can. I know maybe there's an earthquake and that's why it's jiggling. It should be nice and flat usually. So we're basically given a velocity of how fast this water is entering the can, or how fast the water is rising in the can. Let's read our question. So the first question is, find the rate at which the water height is changing. At time is equal to 30 days. No, 30 hours. What are we talking about here? It says days, yeah. Because it says 60-day period, so I know that I'm talking about days here. So what is it really asking for? And you really have 3 choices here. So your 3 choices, is it asking about S of 30? Is it asking about S prime of 30? Or is it asking about S double prime of 30? Those are your 3 choices for this question. So I'll let you read it again in your heads and try to make sense of this. All right. Who has it? Kind of. Fiona has a more confident hand. Yeah, Fiona. It is S prime. Why?
Because the height is S, and so the rate is S.
Exactly, yeah, and I'll type that in here as well. So it's important to know that S of t is height. So if I'm talking about the height changing, that's S prime. So there's another kind of definition for S prime. It's not just the rate of the water rising. It's the I don't know what capitalized S prime of t, and it's gonna auto capitalize because I'm typing. It's kind of annoying. S prime of t is the changing of the height, which means we're really trying to find S prime of 30. So S prime of 30, and this is just a calculator problem. All of these are calculator problems for, I think, this entire unit, essentially. So what does that look like? And then if I come over to our calculator, I'm going to type in our equation, and I've already done that, so I'm a little bit ahead. And I have the next two equations that we're going to be using for the backside. But the first equation is 2 sine of 0.03, and then x in this case, because it only has x. We can't do t. So as long as you have your y1 entered correctly, then how do you do that? I mean, you could graph it. That takes a lot longer. I know that you know the shortcut. I'll show it to you as well. The shortcut here, once you have y1, is you do vars right, enter, enter, to get your y1 function, and then you plug in anything that you want. So you start your parentheses and say y1 of 30. You don't even need to close your parentheses. Just hit enter. Nice and quick, and you say, okay, when I plug in 30 into y1, which is s prime, I get 1.566, always round to 3 decimal places. I haven't checked your test yet, but I know that was a really common mistake on the pretest. Almost everyone made that mistake. So 1.567 if I'm rounding at a 3 decimal place. 1.567. And by the way, if your last digit is a 0, you write the 0. You will always write 3 decimal places. If the answer is 1, you write 1.000. Always have 3 decimal places. Okay, but we didn't finish this problem. Look at the second part of this problem. Indicate units. What are our units here, Andrea? There it is, millimeters per day. And just like in the last unit, in Unit 7, if you get all of the units right for parts A, B, and C, then you get 1 point, generally speaking, on an AP test. So don't make any mistakes if you can avoid it. I know it's hard. All right, any questions on part A? I want to generalize something that's going to be turned into the speed sheet. If I ask for change in blank, or another way of asking this is blank increasing, or is that blank decreasing? All right, just DEC for decreasing, because I'm going to abbreviate. That's literally asking you to look at whatever you're talking about and take the derivative. So let me delete those. We don't need those anymore. It's asking you, take this thing and then take its prime. That's what it's asking for. So since this was asking for change in the height, height was originally s, so we took its derivative. If it's asking you, is height increasing or is it decreasing, then you take the derivative again. So let's look at part B. It's a little bit tricky, but I think this trick will help you. Part B is asking, is the rate now, not just the height, is the rate of the water height change increasing or decreasing at time is equal to 30? What are we looking at now? And again, you either have s prime, or s double prime of 30. Andrea, take a guess. It is, yeah, why? Yeah, exactly. I mean, we're talking about the rate. So rate is the box in this case. And since we're asking is that box increasing or decreasing, we take that s prime and then take the derivative again. We're taking s double prime. Exactly. So because we have this rate, we're looking at s double prime of 30. And how do we do that in the calculator? Can you remind me, Teflon? How do we take the derivative of our y1 function?
I don't know how to do that.
It's a math. Is it math 8 or 9? You can even see down here. Is it? You can even look at your calculator too. Is it deriv or int? 8. Yeah. So math 8. And you type in, okay, the derivative with respect to x of your vars right, enter, enter, your y1 at what coordinate? We're looking at the x coordinate 30 and hit enter. And there it is. So I'll write down our instructions too, just in case we forgot. This is math 8. And then you can get the rest. All right, so what is s double prime of 30? We'll write it in here. We got 0.037, and that's rounded correctly to 3 decimal places, 0.037. Okay, well, we didn't answer the question. The question was asking, is it increasing or decreasing? Fiona, make a conclusion. Yeah, okay, let's type that in. So we say rate is increasing, and did I spell that right? Okay, and we say because s double prime of 30 is 30 is bigger than 0. It's positive. You can say it's positive or bigger than 0, whatever floats your boat. 6 your sub. Perfect. Let's look at part C then. Is the water height increasing or decreasing at time is equal to 30? Who hasn't really answered the tricky part? I'll give it to Teflon again. So Teflon, what are we talking about here? Are we talking about s prime, or s double prime of 30? Because s talks about water height, right? Water height is s. And then now it's asking increasing or decreasing. S prime, exactly. Because water height is just s, and when you ask the increasing or decreasing question, it means take the derivative of whatever it's talking about. If it's talking about rate, take the derivative again. If it's just talking about non-rate, take that derivative. We're talking about here s prime of 30. And we already know s prime of 30. We found it up here in part A. S prime of 30 is 1.567. All right, so Teflon, go ahead and make a conclusion. Is it increasing or decreasing? Yep, increasing. Why? Because, yes, s prime of 30 is greater than 0. Yeah. Done. Yeah, Fiona.
What were we doing where we had, like, the explanation was they're the same sign?
That's speed. Speed is increasing or decreasing. Yep. Great question. I'm trying to think. I don't think there is an increasing or decreasing question here, but it's even easier because this is now calculator enabled, and all you do is you take one and subtract the other, and you're done. They have an increasing function that tells you if the speed is increasing. And in fact, I think that's kind of the backside of what we're doing right now in example 2. Before I go on though, questions on example 1? All right. Example 2 is a very, very typical AP problem because it has a positive and a negative rate. They love throwing both of these at you and hoping that you make a mistake. All right, so Andrea, can you read? But you don't have to read the equations. You can just say capital E.
The rate at which people enter an amusement park is modeled by the function E, where
Yeah, that thing happens. Good.
the rate at which people leave the same park is modeled by the function L, where both E of t and L of t are measured in people per hour, and time t is measured in hours after midnight. The functions are valid for 9 is less than or equal to t, and t is less than or equal to 23. The hours during which the park is open. A. Find the rate at which people enter the park at time t equals 17 and indicate minutes.
Perfect. All right, so we understand the general concept. One equation is people entering, one equation is people leaving, and they're open from 9 a.m. to 11 p.m. because those are like military times, right? 9 to 23. All right, and let's reread the question. We just want a rate of people entering. So first of all, go ahead and enter these equations in your calculator. I've kind of already gone ahead and done that. I did y2 and y3. You can replace y1 if you want. It doesn't matter. I just did y2 and y3, so I have all the equations in here. And how many equations does this have? Like usually on the AP test, you don't want to delete the equations. Okay, it has 10. You don't want to delete equations just in case you want to go back to them. Although in the free response question, you're only going to have 2 different problems for calculator-enabled problems. So usually you're not going to enter all of these equations. All right. Be careful about your parentheses also. Notice that in my y2 and y3, and I'll probably take a screenshot of this just for my notes next year, you have to have parentheses for your denominator, otherwise it will think you're only dividing by x squared. And then it'll think, okay, after I do 8,600 divided by x squared, then subtract 25x plus 163. Parentheses are super important for order of operations here. Okay. So we have the equations entered. What is A asking for? It's asking you to do something on your calculator. What are we really going to do on our calculator? Fiona, you have an idea? Well, careful, because read again what E of t is, and I'll circle or I'll underline the important part. E of 17, that's all it's asking for. And I'll write this in our notes. All it's asking for is E of 17. And I'll add this to our notes also, because E of t, this is a positive rate equation. And it's important to note that that's a positive one. And then L of t is the negative rate equation. I highly suggest when you're seeing your AP test to label positive and negative. You don't need to say rate because you'll probably be so used to seeing differential equations that you don't need to write it. But it is a positive rate and a negative rate. So it's just, if it's asking for the rate is by default its equation. You don't have to take the derivative. And E of 17, we're all really confident at doing that by now, I'm hoping. We just type vars right, enter 2, y2, because that's my E of t function, of 17. You don't need to end the parenthesis, hit enter, and we get 318.518. All right, so we have to be careful in these types of questions. The correct answer does, I'm not going to ruin it for you. I'm going to write this down, and you can tell me if it's correct or incorrect. 318.519. Again, 518 would still be correct on the AP test because you can just truncate and disregard this, or you can round. Does this make sense? I'm going to do units in a second, but that's kind of my hint as to where I'm going. Does it make sense to have a decimal? Ooh, so no, no, and a yes? Let's hear from the no's first. Let's hear from Andrea.
Isn't it talking about people?
Okay. Let's hear from Fiona.
It's not how many people are entering, but the rate at which.
Exactly. So it was like a double trick question. Even though it's talking about people, and you can't have 0.5 of a person, you can have a rate of how many people are coming in. So it is actually okay to have a decimal in this case. But it is always important to check, does that make sense? Because if it's just talking about people, yes, you need to round to the nearest person. If this was just people, I would have rounded to 319. But it's talking about people per hour, which is okay. It's just a rate. I'm talking about this concept. I'm not cutting people in half by doing this. That's a concept of how fast they're going in. All right, what about B? Find the rate at which people leave at time is equal to 17. Again, indicate units. What is it really asking for, Teflon?
L at 17.
Yep, capital L at 17. And again, just plug this in your calculator. For me, that's my Y3. So my var is right, enter 3. Right, enter 3. Y3 of 17. Hopefully you get the same answer as me, 760.769. And I would like to screenshot these for my notes. I should have screenshotted the other ones as well. So 760.769. And again, our rate is the same thing as people per hour. Oh, what happened there? People per hour. All right, finally, some harder questions. Part C. Find the rate at which the number of people in the park is changing at that same time. And you do need to explain. You have to kind of show your work. What do you mean? All right. Well, let me ask a simpler question. Are more people going, are people going into the park or are people really going out of the park? I know the answer is both, but overall, which is the more dominant force, people leaving or entering? What do you think, Andrea? Leaving, yeah. Why? Yeah, so we should have some negative rate then. So I know our answer is going to be negative because our negative rate is bigger than our positive rate. So the answer down here is going to be negative. But what am I really going to do then, Andrea? Well, it's not really asking for a derivative because we're still talking about rates, and these are by default already rates. So no derivatives yet. And I'm not going to leave you hanging. You just subtract them. You just do, and this is me showing my work. This is me doing the explain part of this question. I'm going to say, what is our positive rate, E of 17, minus the negative rate, minus L of 17. And this kind of leads to another thing that's going to be on the speed sheet for tomorrow, which is, what is rate? Rate, by default, is just the positive minus the negative. So in this case, I can come back here, and I'll probably just type it all in again. I'll do vars right, enter 2 of 17 minus vars right, come on, right, enter 3 of 17. And I do indeed get a negative answer like I was supposed to. Again, I should probably screenshot for the notes. And we get negative 442.251. My handwriting is atrocious. Again, we should probably indicate units per, or people per hour, because this is still a rate. I know it didn't ask for it. Just always do it, you'll never make a mistake. And finally, the hardest question of all, well, at least for today's notes, is the amount of people in the park increasing or decreasing at time is equal to 17. And if you think about it, you're like, that's not that hard, Mr. Sindel, and you're kind of right, but you have to be careful. I'll do a volunteer basis on this one. Who wants to take a shot at it? Fiona? Not quite, because E of 17 is the rate of people entering. So if I were to think about what function represents just the amount of people would be the antiderivative of E. So I'll say antiderivative of E is the number. Oh, that's not even true though, because that doesn't represent anything. I'm just trying to think, the number of people in a park is kind of like backwards of E of t minus L of t. Would that make sense? But that's the total change in people. There's not really a good function that gives you just the number of people in the park. But I know if I take the derivative of the number of people entering the park, that would be E. Does that give you a hint as to what the right answer would be? It's the antiderivative of the derivative, which is just the same thing as this question right here. I literally am going to copy paste this and paste it down here. This is, if you did, I apologize. Because again, the amount of people is the antiderivative, but it's asking, is that thing increasing or decreasing, which means I'm going to take the derivative of that. The antiderivative and derivative cancel each other out, and it's wishy-washy. I know there's some mathematician out there watching YouTube who's like, that's not quite correct, and you're right. But essentially, it is still asking, is this E of 17 minus L of 17 a positive or a negative number? It's clearly a negative number, so it's decreasing. And if you think about the broad context of this, it makes sense, because E is just how many, the rate at which people enter, L is the rate at which people leave. So if I do the positive rate minus the negative rate, if I find that rate and I have a negative rate overall, I know overall people are leaving the park, and I ask you the question, I could even ask like kindergartner, like people are leaving the park. So is the number of people increasing or decreasing? Maybe that's a harder question. Maybe that's like a second grader question. But they should be able to tell you, oh, well, you just told me that they're leaving, so it should be decreasing. And the answer is, again, decreasing. But the calculus answer is because the positive rate minus the negative rate is a negative answer.
Is that your explanation, or do you have to write it?
So yeah, I will write the explanation. I'll say, so it's decreasing. That's my conclusion. And why? I'll say at time is equal to 17 to be more specific. At time is equal to 17. Why? Because capital E of 17 minus capital L of 17 is less than 0. There it is. I know it's kind of hard getting our heads wrapped around when to take the derivative and when not. But ever see the word change in something, or is that blank of something increasing or decreasing? Whatever that original blank is talking about, just take its derivative. And in some cases, you have to go backwards before you can go forwards, like in that part D, which is a little bit tricky. But the more that we see this, the better we'll get.